Today's class is on fractions and decimals. Extremely important topic. Extremely important topic for all aptitude exams. For all aptitude exams. Very important topic. I request each and every student's help to share this class link which was sent to your WhatsApp to as many students as possible. Extremely important topic. As usual, we will discuss concepts, we will discuss shortcut tricks, no traditional methods, shortcut tricks, no traditional method. If any student is looking out for any traditional formula based method, I am sorry, I will not be able to meet your expectation. All my YouTube live classes are very conceptual and it discusses the why behind the answer, why that answer is incorrect more than just doing the answer. Right? Now before we start the class, very important information. Any student who is listening to the class for the first time because of your friend's reference, kindly WhatsApp to this number to get all the class updates. Kindly make a note of this class. Our WhatsApp number 8296989020. Through this WhatsApp number you will get all the class links or any of the exam notification or any of the class PDFs. Any student who missed the yesterday's session, if you want the class PDF by 2 o'clock, you will get the class PDF from this WhatsApp number. In case if you want the class PDF effective from tomorrow, on the PPT I will annotate, so I will try to give you the solution key as also as a part of the PDF, but that will not be helpful because only steps are there. Kindly WhatsApp to this number, that is the first key point. In case you got any doubts in any of the class, this is our email ID, support@anilnairclasses.com. Faculties will look into every day this email and they will answer your doubts. support@anilnairclasses.com. Why these YouTube live classes? What is that we are trying to achieve because of the YouTube live classes? It helps us to eliminate the use of pen or pencil and it helps a student learn the concepts logically. It helps the students to know beyond just a formula based lecture. Do not skip in between. If you are sitting at the beginning of the lecture, kindly listen to the entire lecture so that most of the concepts will be covered. And best way to learn my class is to take a notebook and a pen or a pencil and make a note of all the concepts. Take a notebook and a pen or a pencil. As and when I am discussing a concept, write down in your notebook. Nothing beats other than the handwritten notes. Nothing beats other than the handwritten notes. The best way to learn any concept is to develop a handwritten notes. Shall we all start the class? Kindly reply it in the live chat. Should we start the class? Kindly reply it. Shall we start the class? I want each and every viewer to reply it in the live chat so that I can start the class. So this is about me. More than 1,000 students. I might have taken session more than 500 times. So pay ultra attention to the lecture. These concepts you will not find it in the regular textbook. Shall we start the class? So we will start the class. Please write down heading. Few important key points. Which we will discuss. Then we will start the class. Heading, please write down fractions and decimals. First 5 to 10 minutes I will discuss few concepts, 5 to 10 minutes basics, then we will get into a problem solving. 5 to 10 minutes basics which we will discuss, then we will get into problem solving. Now listen carefully to the basics. First one, please write down. First one, before we start with the fractions and decimals, first let me discuss what is a natural number. Natural numbers. Natural numbers. Natural numbers are nothing but the numbers which can be counted, or the numbers which can be counted are called natural numbers. The numbers which can be counted, numbers which are used for counting, are called natural numbers. Natural numbers are from 1, 2, 3, 4 and so on. The numbers which you can count it, there are 2 pens, there are 5 pencils, there are 4 bags, there are 5 people, there are 10 animals. Anything that you can count it is called natural number, are called natural numbers, are called natural number. 0 is not a natural number. 0 is not a natural number. Number which can be counted is called a natural number. 0 means it is not existing. If it is not existing, it cannot be counted. Natural numbers are called as counting numbers, and it is denoted by capital N. And it is denoted by capital N. Natural numbers are called as the counting numbers, and it is denoted by capital N. After that, the invention of 0 has resulted in a new numbers. Invention of 0 has resulted in a new number. That numbers are called whole numbers. That numbers are called whole numbers. Whole numbers. Whole numbers is nothing but natural numbers. Natural numbers is 1, 2, 3, 4 with 0 addition. With 0. With 0 addition. Natural numbers will start from 1, whole numbers will start from 0. Write down as it is the way I am saying it, because each and everything whatever I am saying it will be useful for problem solving. Before we discuss what is a fraction, we are discussing what is a natural number and what is a whole number. Natural numbers are called as counting numbers. Whole numbers are denoted by W. 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 First slide, I hope it is clear. Natural numbers and whole numbers. Next slide. Now, then came integers. Then came integers. What do you mean by integers? These integers came because of the invention of positive and negative numbers. Positive or negative numbers. Positive or negative numbers has resulted in set of integers. Integers is nothing but negative, next is 0, and next is positive. -3, -2, -1, 0, 1, 2, 3. And so on. Negative numbers, positive numbers and 0 are called as integers. Or in simple words, integers is nothing but negative natural numbers, positive natural numbers and 0. Negative natural numbers, positive natural numbers and 0, all three combinedly are called as integers. Natural numbers are the numbers which can be counted. Invention of 0 has resulted in a new set of numbers which we call it as whole numbers. Then came negative, 0 and positive. Then came integers. I hope it is clear. Next one important point. 0 is neither positive nor negative. 0 is neither positive nor negative. 0 is neither positive nor negative. Positive integers which are positive numbers means which can be counted. They are also called as natural numbers. Positive integers are also called as natural numbers. Positive integers are also called as natural numbers. Non-negative integers. These are synonyms. Non-negative integers are also called as whole numbers. Please make a note of this. In the questions, maybe the terminology might be, instead of saying whole numbers, they might ask you how many non-negative integers are same. All are non-negative integers means whole numbers. Non-negative, other than negative. Integers is negative, 0 and positive. Non-negative, other than negative. That means 0 and positive. Positive integers are called natural numbers. Non-negative integers are called whole numbers. First we discussed what is a natural number, then we discussed what is a whole number, then we discussed what is an integer. Now we will get into our topic. Next is fractions. This is our topic of discussion today. Fractions. Fraction means anything which is a part of 1. Anything which is a part of 1 is called fraction. Anything which is a part of 1, which is a fraction. Right? Suppose if I say 1 by 2. 1 by 2 of a part of 1. 1/10 of a part of 1. 2/3 of a part of 1. 4 by 7 of the part of a 1. There could also be some fractions where numerator is greater than the denominator. 15 by 4, which is in mixed fraction is 3 by 4. That means 3 parts and 3/4 of a part of a 1. 3 and 3/4. So if you observe in the fractions, anything which is a part of a 1 is called a fraction. Anything which is a part of 1 which is called a fraction. Now in fractions, there are two kinds of fractions are there. One is a proper fraction. Another is an improper fraction. One is a proper fraction, another is an improper fraction. A fraction will have numerator and denominator. NR refers to numerator. DR refers to denominator. There are fractions, there are two parts are there. One is proper fraction and another is improper fraction. Proper fraction and improper fraction. Proper fraction means the value will be less than 1. Value means a fraction is of the form numerator by denominator less than 1. Numerator is nothing but less than denominator. A proper fraction is a fraction where numerator is less than denominator. A proper fraction is a fraction where numerator is less than denominator. Improper fraction means it is greater than 1. That means numerator by denominator greater than 1. So this is nothing but numerator greater than denominator. Improper fraction means numerator greater than denominator. Proper fraction means numerator less than denominator. Improper, which is not proper means which is not numerator less than denominator. So other case is numerator greater than denominator. Proper fraction means numerator is less than denominator. Improper fraction means numerator is greater than denominator. Again in a new slide I will write it. Just write in the same way, sir. In the proper fraction, what is the definition of a proper fraction? Fraction is less than 1. That means numerator is less than denominator. Few examples where numerator is less than denominator. 2 is less than 3. So 2 by 3 is a proper fraction. 7 is less than 10. 7 by 10 is a proper fraction. 5 is less than 8. 5 by 8 is a proper fraction. 5 by 8 is a proper fraction. Right? What is improper fraction? Improper fraction means which is not proper. numerator and by denominator greater than 1. That means numerator is greater than denominator. Greater than denominator. Examples are 7 by 2. 7 by 2. 7 is greater than 2. 5 by 4. 5 is greater than 4. 13 is greater than 10. 13 is greater than 10. All these improper fractions can be written in a mixed form. Mixed form means they can be converted into a proper fraction. For example, 7 when divided by 2, 2 3s are 6, it is 1 by 2. So this is nothing but 3 1 by 2. 3 1 by 2. 3 1 by 2. If you observe, this is nothing but dividend. This is nothing but dividend. This is nothing but divisor, number which is dividing. This is nothing but quotient. This is nothing but remainder. So, any improper fraction can be written as quotient, remainder by dividend. Why? Because dividend is divisor. So it is nothing but dividend is nothing but divisor into quotient plus remainder. Divisor into quotient plus remainder. Make a note of it, sir. In improper fraction can be converted into a mixed fraction. In the mixed fraction, dividend is nothing but divisor into quotient plus remainder. So 3 1 by 2 is 3 2s are 6, 6 plus 1 1 by 2. 5 by 4 is 5 1 by 4. Proper fraction, numerator is less than denominator. Improper fraction, numerator is greater than denominator. Numerator is greater than denominator. Now, one important observation in proper fraction which will be extremely useful in our DI. Proper fraction. A proper fraction is of the form numerator by denominator which is less than 1. Suppose if denominator minus numerator, if it is same, if denominator minus numerator it is same, 1 by 2, 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1, 6 minus 5 is 1. Right? Simple. Lowest numerator, as the numerator increases, the value will decrease. In a proper fraction, the fraction increases, the fractional value increases as numerator increases, as numerator or denominator increases. Extremely important point. Please make a note of it, sir. In a proper fraction, what do you mean by a proper fraction? Numerator less than denominator. If numerator is less than denominator, lowest numerator, lowest denominator will be the lowest value. In simple words, lowest numerator and lowest denominator. Lowest numerator, lowest denominator, the value will be lowest. As long as denominator minus numerator difference is same. What if it is not same? That also we will discuss. This is in proper fraction. Every concept which I am explaining at the beginning of the class, it will be useful as the class progresses. You will see some important concepts which I am using. Proper fraction, numerator is less than denominator. In proper fraction, lowest numerator, lowest denominator, the value will be lowest. Next point. Improper fraction. In improper fraction, numerator by denominator is greater than 1. If it is greater than 1, simple concept. Highest numerator, highest denominator, the value will be highest. value will be highest. As long as denominator minus numerator is same. As long as denominator minus numerator is same. We are discussing a case where denominator minus numerator is same. For example, 3 by 2, 4 by 3, 5 by 4. 3 minus 2, 3 minus 2, 1. 4 minus 3, 1. 5 minus 4, 1. Highest numerator. I hope it is clear. Greater than. Or we will write like this. Instead of writing like this, I will write like this. Or I will write like this. Value decreases as the numerator denominator increases. It's a simple point. Value decreases as the numerator and denominator increases. Are you all with me? This is the best way to write it. Value decreases as the numerator and denominator increases. Improper fraction. First one, value will be decreasing. Right? Proper fraction, improper fraction. Next comes the most important concept for today's class, rational numbers. Rational numbers is derived from the keyword ratio. Ratio means anything which you can write it in fraction format. Any number which you can write it in the form of P by Q. P and Q are integers. Q not equivalent to 0 is a rational number. Rational number is derived from the keyword ratio. Ratio means you have to write it in a fraction format. Any fraction format will be of the form P by Q. P and Q are integers. All integers are nothing but rational numbers. All integers are nothing but rational numbers. 2 can be written as 2 by 1. It can be written as 4 by 2. It can be written as 6 by 3. It can be written as 8 by 4. A rational number is derived from the keyword ratio. Ratio means fraction. So a fraction format will be P by Q. Q not equivalent to 0. Q not equivalent to 0. I hope it is clear. Now comes the very important table. There are integers. There are decimals. I'll write like this. There are integers and there are decimals. This combination is nothing but rational numbers. Integers is a rational number where the denominator is a factor of numerator. In decimal, there are two varieties. One is a terminating decimal. Terminating means which stops 0.23, 0.78. These are all terminating decimals. Next is non-terminating, which does not stop. Non-terminating decimal. Terminating means which terminates, which stops after at a point. Non-terminating, which does not stop. Now which does not stop means again two varieties. any digit will it be repeated, recurring of digits or repetition of digits. Non-recurring. Non-terminating means which does not stop. Recurring means, for example, 0.343434. 34 only is getting repeated. 34 only is getting repeated. Non-recurring. Non-recurring is 0.123567 and everything. There is no digit which is getting repeated. So again I am saying, in decimals there are two types: terminating, terminal, terminus. Terminating means which stops after a time, which stops after at a particular time. Non-terminating means which does not stop after a time. Which does not stop means which will keep continuing. If it keeps continuing, are there any digits in that decimal which keeps repeating? There are no digits which gets repeating. If they get repeated, it is called recurring. If it does not get repeated, it is called non-recurring. Extremely important. Today the entire class is on recurring, terminating and non-recurring. The entire topic will be based upon this one. In rational numbers there are integers and decimals. In decimal, terminating and non-terminating. Non-terminating, it will not stop. So if it does not stop, what will happen? The digits will keep continuing, or same digit will keep continuing, or different digits will keep continuing. Same digits, if it keeps continuing or if it keeps repeating, it is called recurring decimal. If it does not get repeating, it is called non-recurring decimal. Non-recurring decimal. I hope you are all there with me. Again I will discuss the last slide. Terminating decimal. After this we will get into problem solving. Terminating decimal. Terminating, which terminates 0.12, 0.784, 3.416. These are all terminating. Recurring decimals. Digits will be repeated. 0.33333. 3 is getting repeated, which is called 0.3 bar. 0.3 bar. This is nothing but a pure recurring decimal. Suppose if it is 0.234234, which is nothing but only 34 is getting repeated. So it is whatever the digits that is getting repeated, on that keep a bar. This is nothing but a mixed recurring decimal. One digit has stopped and 34 is getting repeated. What is non-recurring? Non-recurring. It is not stopping but with different digits. There is no particular pattern. In recurring decimal, there is a pattern of digits getting repeated. Pattern of digits getting repeated. That is a recurring decimal. Pattern of digits getting repeated. Non-recurring. There is no particular pattern. There is no particular pattern. If there is no pattern, write, for example, 0.123789235674. There is no particular pattern. In recurring decimal, there is a pure, only few particular digits are getting repeated. After dot, there will be some more thing. Are you all with me? Recurring is kept by a bar on the digit which is getting repeated. Another important observation. Left of the dot, if there is a bar which is nothing but minus a plus point bc. Suppose 2 bar dot 53, which is nothing but minus 2 plus 0.53. This I will discuss in detail in logarithmic chapter when I discuss a mantissa concept. I will discuss this. Dot can also be there to the left of dot. After dot, that means it is to the left of dot also it could be there. A bar dot BC is minus A plus point BC. Minus A plus point BC. Last one. What is last one? Irrational number. Irrational number. Irrational number. Irrational number. Irrational means which is not a rational number. Which is not a rational number. Which is not a rational number. Which is not rational number. Numbers which are not rational numbers. What is a rational number? Which can be represented in the form of P by Q. Which cannot be represented in the form of P by Q. Which cannot be represented in the form of P by Q. Which are not terminating. Which is not terminating. The symbol is for not. Which are not terminating. Which are not recurring. So it is nothing but non-terminating. Non-terminating. Non-recurring values. Any number, if it cannot be represented in the form of rational number, are called irrational numbers. Irrational number cannot be written in the form of P by Q. First point, irrational numbers are not terminating. Irrational numbers are not recurring. Irrational numbers are not recurring. Irrational numbers are not recurring. Now in irrational numbers, classic case of irrational numbers. Classic case of irrational numbers. Classic case of irrational number. Pi is an irrational number. E is an irrational number. Phi is an totient function. It is an irrational number. Phi, E, Phi, right? These are all irrational numbers. Root 2, it is an irrational number. Root 7, it is an irrational number. Root 9 is 3. 3 can be written as 3 by 1. Root 9 is an rational number. Root 9 is an irrational number. Almost all the constants which we use in maths and physics, whatever the constant that we use in maths and physics, almost all the constants are nothing but irrational numbers. All the constants are nothing but irrational number. I hope it is clear. Till now we discussed the basics. Now we will get into problems. Real numbers is nothing but rational numbers plus irrational numbers. Rational numbers plus irrational numbers. Rational numbers plus irrational numbers. Real numbers is nothing but rational numbers plus irrational numbers. I hope it is clear. I hope it is clear. Right? Till now, is it clear? Or if you want a clear clarity on the table, the superset of all the numbers is real numbers. Superset of all the numbers is real numbers. Real numbers is nothing but a combination of rational numbers and irrational numbers. Rational numbers and irrational numbers. Irrational numbers. Irrational numbers are nothing but numbers which cannot be in the form of P by Q. Pi, root 2, cubed root 3, fifth root 7, E. All these are irrational numbers. Pi is approximated to 22 by 7. It is not equal to 22 by 7. So pi is an irrational number. In rational numbers are of the form P by Q. In that one, two types. What are the two types that we discussed? First it is integers. Next it is fractions. Fractions. In fractions, what we discussed, a fraction can be written in the form of a decimal. Fraction can be written in the form of a decimal. So, in decimal what we wrote, one is terminating and the next one is non-terminating. Next one is non-terminating. In non-terminating, what we wrote? It could be recurring or it could be non-recurring. It could be non-recurring. It could be non-recurring. In integers, what we wrote? Whole numbers. Whole numbers. And negative integers. In whole numbers, there is natural numbers. In natural numbers, there is a prime number and there is a composite number. In natural number, there is a prime number and there is a composite number. I hope the table is clear. I hope the table is clear. Till now, any doubts? Now we will get into a wonderful problem solving. Wonderful problem solving. Till here, real numbers, rational numbers, irrational numbers. And if you do not understand this basic difference of what is terminating, what is recurring, now the next slide will give us foundation to solve the problems. I hope it is clear. Note, please write down, sir. Note. Now here onwards, the intermediate level questions will be used. Note. First point, digital sum is used. When to use digital sum? Digital sum is used only for terminating decimals. Digital sum is used only for terminating decimals. Digital sum is used only for terminating decimals. Digital sum is used only for terminating decimal. Second point, digital sum is used when the denominator is either a power of 2 or a power of 5 or powers of 2, 5 both. Extremely important points, sir. Please make a note. Digital sum is used only when the denominator is either a power of 2 or a power of 5 or a power of 2, 5 both. You cannot use digital sum in fractions where the denominator is any value other than 2, 5. That is the reason a percentage is a by 100. 100 is nothing but 2 square into 5 square. So in percentages, I can use digital sum. I hope, please make a note of it, sir. Digital sum is used only for terminating decimal or the decimals where the digits are not repeated, which stops. Digital sum is used only when the denominator is either a power of 2 or a power of 5 or a power of 2, 5 both. First key point. Then you will be able to solve the toughest questions very easily. Power of 2, 5 both. First point, I hope it is clear, right? Second point. Please write down the second point. Then fadafat we can solve the problem. Second point. If P is a prime number, P not equivalent to 2, 5. If P is a prime number, P not equivalent to 2, 5. 1 by P. P not equivalent to 2, 5 means it will not become a terminating decimal. It will become a recurring decimal. with a cyclicity of period of factor of with a cyclicity of factor of p minus 1. Please make a note of it, sir. Please make a note of it. If we discussed what happens if the denominator is only powers of 2 or powers of 5 or powers of 2 comma 5 both, then we have to discuss the reverse case also. What is the reverse case? What if it is not power of 2 comma 5? If it is not power of 2 comma 5, it becomes a recurring decimal. Then if it becomes a recurring decimal, then the digits will be repeated. In what way it will be repeated? It will be repeated in factor of p minus 1. This is derived from Fermat's theorem. A power p minus 1 divided by p, it is 1, where a comma p are co-prime numbers and p is a prime number. This is a derivative from Fermat's theorem. Write down this, then I will explain you the problems. 1 by p. Suppose if you want to know 1 by 7 is nothing but 0.142857 bar. 142857 only will be repeated. 7 is a prime number. So repetition of digits will be in a factor of p minus 1. 7 minus 1 is 6. 6 digits are repeated. I hope it is clear. Till now, all the concepts are clear? I hope all the concepts are clear. Shall we go to problem solving? Shall we solve problems based upon whatever we discussed? Shall we solve problems? Kindly reply it in the live chat. Shall we solve problems? Reply it in the live chat. Shall we solve problems? Shall we solve problems? All the concepts, are they clear? Digital sum is used only for terminating decimal. It cannot be used for recurring decimal. First point, when it will be terminating, when the denominator is either a power of 2 or a power of 5 or the powers of 2 comma 5 both. That is clear. Next, if it is a recurring decimal, now let us discuss the problems. First one. Now see here. Which of the following are? First one. Listen carefully. Identify which of the following are rational numbers. Unfortunately, after the class is over, this class entire video will be present only to the students who buy my latest package, Anil Nair's Aptitude special videos. I am going to discuss 60 to 80 hours of new content, absolutely 2019. I am going to create a separate folder today. Those who purchase it, today's class, within 2 days it will be visible in that folder. Other students who purchased last year, they have to upgrade the package. Thank you very much. Yesterday 85 students have already upgraded this, only because you want to know the content. Now see, identify which of the following are rational numbers. Simple basics. Identify which of the following are rational number. What do you mean by a rational number? Rational number should be of the form p by q. Rational number can be terminating. Rational number can be terminating and rational number can be recurring. No need of telling answers. I don't need the answer. It can be terminating or it can be recurring. 5 by 9. 9 is 3 square. If the denominator is a prime number other than 2 and 5, then it will be a recurring decimal. A recurring decimal is a rational number. So first one answer is rational. No answers needed. Listen to the explanation. Denominator is a prime number other than 2 and 5. 9 is derived from a prime number 3 square. 0.333. 3 is getting repeated. 0.3 bar. So it is a recurring decimal. A recurring decimal is also a rational number. A recurring decimal is also a rational number. Root 2. Root 2 cannot be expressed in the form p by q. Root 2, it cannot be expressed in the form p by q. Third one answer is irrational number. Third one answer is it is an irrational number. Third one, it is an irrational number. 22 by 7, which is in the form of p by q, where p and q are integers. 22 is an integer, 7 is an integer. So fourth one, 22 by 7, it is a rational number. 22 by 7, it is a rational number. Pi. Pi is nothing but circumference of a circle by diameter. Pi cannot be expressed in the form of p by q. Pi cannot be expressed in the form of p by q. Irrational number. Irrational number. Irrational number. Only write down, listen to the explanation. 0.5735735373. It is nothing but non-terminating. It is nothing but non-terminating. It is not non-recurring. Non-terminating, non-recurring decimal. Non-terminating, non-recurring. Non-terminating, non-recurring. Non-terminating and non-recurring. I hope it is clear, right? Non-terminating and non-recurring. So these is nothing but five 735. Here 735 is repeated. 735. Oh, sorry. Here it is. Here it is written in the question that it is getting. It is 573 is getting repeated. So it is mentioned. So it is a recurring decimal. It is a recurring decimal because it is written here. I have not noticed this. Recurring decimal. Recurring decimal is a rational number. Recurring decimal is a rational number. I hope it is clear. I have not seen that 573. Next one. F. Next. 563962460666496. Non-terminating. Non-terminating. And it is not, digits are not getting repeated. Non-repeating. Non-terminating, non-recurring. Non-terminating, non-recurring. Which is an irrational number. Which is an irrational number. Root 5 power 100. 5 power half power 100. Which is 5 power 50. 5 power 50 is nothing but an integer value. Integer can be represented as a rational number. So this is a rational number. This is nothing but 5 power 50 plus 1 by 5 power 50. Again a rational number. Again a rational number. Again a rational number. I hope the basic idea it is clear. Non-terminating, non-recurring. I will use beautiful answer options, sir. Just to hold on. From basic, intermediate, advanced, I will discuss as many concepts as possible. Now, see carefully before this. Suppose there are a lot of questions which we will solve. Now, see here, sir. Listen care. See this question, 12th question. 8 by 27. 8 by 27. 8 by 27. First option is nothing but 0.296 bar. 0.296 bar. Second option is nothing but 0.296 bar. Third option is nothing but 0.29696. 296 bar. Fourth option is 0.296. 0.296. Now we should know how to convert these fractions. Just let me see. 9 by 14, 9 by 14. Okay, I think conversion is there. I think 14th, 15. 1 minute, sir. I am just want to discuss few good questions before we solve it. Right, we can come from the 20th question. See the 20th question. Wherever the concept is there, I am not going to solve. See the 20th question. Original competitive examination question. Then I will discuss different models at a time. M equivalent to 0.1 plus 0.1 square plus 0.01 square. 0.3 plus 0.03 square plus 0.003 square. Anil Nair's way of solving the question. Apply digital sum. If I apply digital sum for 1.32 will be sum of the digits till you get a single digit number. 1 plus 3, 4, 4 plus 2, 6. So apply the digital sum. 0.1 it is 1. 0.1 it is 0.01, sir. It is 1. 0.001 it is. 1 plus 1 plus 1 which is 3. Please make a note. 0.1 plus 0.01 square plus 0.001. N is nothing but 0.3 it is 3. 0.03 square. 3 square 9. Again also 9. If you add the digits to 9 or multiples of 9, digital sum will not change. So M plus N is nothing but 3 plus 3, 6. Answer digital sum should be 6. Delete the digits whose sum is 9. 3 plus 3 plus 3 is 9. 1 plus 1 plus 1 digital sum is 3. It is not possible. 3 plus 3 plus 3. 3 plus 3 plus 3. So these is nothing but 1 plus 1 3. These is not possible. 3 plus 3 6. 6 plus 7 7 8 9. 4 not possible. Next 9 over 4 plus 1 plus 1 6. Answer for this question is option A. Option A. Why? Because digital sum is 6. Why? Because digital sum is 6. This is method 1. Method 1 to solve. Apply digital sum. Question is 0.1 plus 0.01 square plus 0.01 square. 0.1 digital sum is 1. 0.01. The M question is like this. 0.1 plus 0.01 square plus 0.001 square. There is a digit 0 which is missing. So 1 plus 1 plus 1 is 3. 3 plus 9 plus 9 is 3. M plus N is 3 plus 3, 6. Answer digital sum should be 6. What if more than one answer option has the same digital sum? This is method 1. Now write down method 2. First I am discussing one model. Method 2. Now if you see here, since the series is decreasing, use approximation concept. What is approximation concept? M is nothing but 0.1. Next it is 0.01 square. Next it is 0.001 square. 001 square. Now see here, these are all very small values. N is nothing but 0.3 plus 0.03 square plus 0.0003 square. These are also smaller values. So M plus N, answer should be just greater than 0.4. Answer should be just greater than 0.4. Answer should be just greater than 0.4. Because answer is just greater than 0.4. third option is eliminated, fourth option is eliminated. Now then you can use digital sum. I hope the concept is clear, right? 0.01 whole square is point followed by 3 zeros ending with 1, that is very small. So because the values are decreasing, use approximation. Just by looking at a question, you can say that 0.13 is out. Here n value itself is 0.3 plus something, n itself is 0.3 plus something. How can it be 0.1? M plus n itself is 0.3 plus 0.1, which is 0.4. How can it be 0.3? Third option and fourth option are directly eliminated just by looking at an answer option. Answer options are not only used to tick mark, but also used to eliminate incorrect answers. I hope approximation logic and digital sum logic, I hope it is clear. I hope it is clear. This is one way to solve few fractions and decimals.
Press the bell icon on the YouTube app and never miss another update.